So in my astronomy lab, my goal is to have the students be able to make an evidence-based conclusion from data. And that data can be collected on the internet. It can be collected from their own personal experience, but we have them collected on the internet. And so they have to be able to ask an answerable research question, be able to gather evidence to answer that question, and then make a conclusion from that evidence. So those are like my big three main learning goals. The assessment that I have the students do is that they have to actually do the process, and they are supported in doing that beforehand. They first have to go through looking at evidence. They have to look at some conclusions and evaluate how those conclusions, do they match the evidence? They have to look at some data and make their own conclusions. And then they have to actually go through the whole process themselves. And that process the process of going through it themselves actually only really takes about 20 minutes for them to generate an answerable research question, create a procedure, gather their data, and then make their evidence-based conclusion. That actually only takes about 20 minutes. There's about an hour beforehand of helping support them to get there. As an example, I have this particular exercise, and it's called Investigating the Hubble Ultra Deep Field and Galaxies. So the Hubble Ultra Deep Field is an image of a small piece of sky that has many, many galaxies in it. And so they have to kind of look at that picture, that image. It's an actual astronomical image, and they have to first gather some evidence. They have to look at it, then gather some evidence, and then they'll go on to make their research question using that image. So the thing that we first do is that they first are going to explore what's going on. So the exploration is just to look at the image and then first just look at the things that are in it. There are a few stars in the image, but most of the things are actually galaxies. And then they have to try and count how many galaxies, but you can't count all the galaxies in the universe, and so you only count a little piece. And so we're looking at different tools that astronomers use. We assume the universe is the same everywhere. And so that's one of the things that they're examining with this. So first they're looking just at what they see there. They're practicing evidence-based conclusions. They look a little bit more in depth. And then they start into phase 2, which, given some evidence that they gather themselves, and then they are given a conclusion, and they have to evaluate that conclusion. So they have to actually, in this process, they have to look at different galaxies in the image, and they have to draw them. And then a hypothetical conclusion was, are all the galaxies perfectly round, or are they slightly elongated? And then they have to explain their reasoning why they think that statement is true or false. So that's step 2, or phase 2. Then phase 3 is they are given a set of data. And so that's what this is. They're given a data table. And given that data table, what conclusions can they then draw? So they're practicing more and more. Then phase 4 is actually making a procedure, an appropriate procedure, a specific procedure as well. So that given an actual research question. They're given the research question. They don't have to create it themselves, but they have to create the procedure. Then phase 5, which is the big kahuna, that's the big thing that they're supposed to do, is to actually formulate the question. And they have to get it okayed by a TA first, by the instructor first. And then they start gathering their actual data after they've made their procedure. Then they make their evidence-based conclusion. So that's like the big thing that we look at. The rubric that we use is actually entitled here, this Inquiry Self-Assessment Success Guide. And so it is exactly the same rubric that we use to assess them as they get to assess themselves, to make sure that they have a really great project. We look at the project and we look at the question and think, oh, how could somebody answer this? Then Does the plan actually yield the evidence? Does the procedure yield, is it going to yield the evidence? Is it going to be specific enough? Can I actually recreate it? Recreate my students' data table, or kind of close enough, or something very, very similar. Then we look at how much evidence has been collected. Is it sufficient to actually answer their question? Because sometimes, it's really not sufficient. Then, but most of the time it is. The students are great about this. And then in their actual conclusion statement, are they claiming more than the evidence supports? We don't want them to make huge, grandiose statements. We want them to make statements that are reasonable for the evidence they have actually collected. So then looking at assumptions, because sometimes an assumption is good, like we assume the universe is the same everywhere. That's a good assumption to make. But they can't assume, things like that all nearby galaxies are yellow. So, yeah. And then do they actually answer the question? This is something that not every researcher actually even does, is do they actually answer their research question? They could add more after that, but they do have to actually answer it in their conclusion. So that is how we actually assess this. Once the students have actually carried out a few different research projects and had a few different answerable research questions that they've generated and evidence-based conclusions, then we have them start looking at kind of bad research or incomplete research reports. There's parts of the research reports that are good and parts of the research reports that are lacking. And these would be mistakes commonly made by students. So we do find that by assessing other things, their reports do improve afterwards. After having done this, they are definitely better. Usually a few percentage points better after they've actually completed this. So they are asked different questions, and actually most of those questions are the same kinds of questions that we use on our grading rubric. Has more evidence been, has more evidence, or is more evidence needed? Is the procedure actually a good procedure? Is it going to yield the evidence that you need? And then the students have to, just like look at it and circle and then start explaining. They are also asked to do a summary, which is, of course, a big overarching summary, looking at common problems to avoid in a research project, how to deal with assumptions, and then they have to summarize what makes a solid inquiry research project so that they can actually put that in words. They have to commit to something by actually putting it in words. Yes, we do assess them in their critique because we feel that the actual communication of what they learned is really, really important. We do mostly assess the summary. That's the biggest part of the assessment for that particular portion of the lab. And if they're able to communicate what makes a good project, then they are usually making really good projects after that.